Welcome to this webinar, All Electric Building Benefits for Builders. My name is Hannah Brugman. I'm the Director of Initiatives here at Build It Green. We're a nonprofit based in Oakland, bringing residential green building into the mainstream with credible, accessible resources and innovations, including the Green Point rated home certification program. Today, we work with a broad range of partners to envision new approaches to home and neighborhood building that foster health for all in the broadest sense. A few logistics before we go ahead and jump into the webinar. There's both a Q&A box at the bottom of your screen and chat. Feel free to ask questions as we go along in either Q&A or chat. We'll have a period of time after the presentation when we'll go ahead and address most of those questions, although we may try to answer some as we go along if they're a little bit more straightforward. So please feel free to be generous and enthusiastic with those questions. If you're having any trouble hearing or any other kinds of tech issues, please feel free to email us hello@builditgreen.org. We'll check it out, or you can go ahead and ask for help in the chat if that's working for you. We're recording this session. The recording will be available afterwards. We will also share a PDF of the presentation in a follow-up email after this. So don't feel like you have to take a lot of notes. We will be sharing that with you after this. So today, our speakers are coming to us from Consol. They're a small California business with 35 years of experience in energy efficiency consulting, program management, and technology integration. The business offers leading research and energy consulting that applies knowledge of current building practices and codes to increase efficiency while ensuring cost effectiveness. So we're really grateful for Consol to be here today. And in particular, I'd like to introduce the two folks who will be giving the presentation and answering questions today. The first is Amy. Amy Valine is a research analyst at Consol, a California company, like I just said, specializing in energy efficiency consulting. Her bachelor's is in environmental science, and she's responsible for analysis and reporting in support of various energy efficiency research projects and other client deliverables at Consol. We also have with us Dr. Will Allen. He's a senior technical consultant at Consol. He's responsible for the management, planning, and technical oversight of Consol's energy efficiency projects. Prior to Consol, he was a senior development engineer at Western Cooling Efficiency Center in UC Davis, specializing in the development and testing of innovative, high-efficiency air conditioning systems. He has both a BA and a PhD in physics and a Master's of Science in electronic materials. We're super grateful to both Amy and Will for being here with us today. Amy's going to start by giving a presentation, and We'll be answering questions throughout, and then again, taking those questions at the end. So Amy, thanks so much for being here. Please take it away.
Yeah, okay, let me set up the slides.
Your sound is a little low.
Okay, yeah, I got it. Are you seeing the slides right now?
Not yet.
Okay, perfect.
Now we are.
There it goes. Okay, great. Let me put this. Okay, so awesome. Thanks everyone for being here. I'm happy to present this information today, and thank you, Hannah, for the wonderful introduction. As they mentioned, my name is Amy. I am a research analyst with Consol, and we are a building energy efficiency consulting firm based out of California, Sacramento specifically. And so this webinar today is going over clean energy homes, all electric buildings under the 2022 code specifically. So this is going to cover costs, benefits, and savings that can be expected for builders and for buyers of these homes. And also I wanted to give a special thanks to Southern California Edison for funding this presentation, and also Engage Marketing for helping us to format these slides. Specifically, a lot of the examples that we're going to reference throughout the study are from Southern California Edison territory. So the results might be more specific to climate zones in Southern California. So if you have different experiences, the location specificity could be part of the reason why. I'm aiming for this presentation to take about 45 minutes and allow time for questions at the end. But also, yeah, people might be interjecting with questions to field as the presentation's going on. So yeah, hopefully 45 minutes for the content and then additional 15 for questions so we can round out the hour together. And as Hannah mentioned, I work for Console, and this is just a brief overview of some of the additional services that we provide. So Console is a building energy services company providing a range of services to the building industry, like consulting services to builders, developers, manufacturers, and other industry stakeholders. And then one of our biggest services is also modeling and energy efficiency analysis. And so we help clients understand and better navigate the requirements of California's Title 24 regulations. And so this just provides some overview of what we do. And so today I'm going to be talking about all electric home building, new construction, all electric homes. And so this might seem like a cutting edge futuristic idea that's never been done before, but actually this is something that we've seen before. A blast from the past would be these gold medallion homes from the 1960s and 1970s in the US actually. So even though all electric is part of a bigger conversation now, it isn't necessarily a new concept for home building. These gold medallion homes in the 1960s were seen as the wave of the future. And the idea was that electric power was going to replace coal at the time. And so these homes were promoted by GE with a commercial featuring actually their spokesperson, future President Ronald Reagan, as you can see here. And so this might seem like a brand new concept, but it's an idea that we're revisiting and something that's been done before. And so throughout this presentation, I'm going to be talking about some of the benefits and also concerns that we can anticipate from builders and also from the customers who ultimately buy these all electric homes. And so to begin, what are some of the builder concerns that we can anticipate ahead of time? And so these are some of the most common questions that we can anticipate as we transition to all electric homes. And so some of these questions might be, well, how is the code going to change? And then of course, what are some of the cost implications and compliance consequences of transitioning from mixed fuel to all electric? And then at the bottom line, how is the customer also going to benefit from this transition? So here you'll see just a framework of the structure of the rest of the presentation, some of the topics that we'll be covering, and generally the sequence of things. So to begin, we're going to talk about the regulatory path and some of the legislative framework that's in place, acting as a driver for this electrification transition. So the first major one is this executive order from September of 2018 that set a new statewide goal to achieve carbon neutrality as soon as possible, no later than 2045 as the end date. And so there's several ways that we're going to go about achieving this as the state of California. And so 3 major plans include decarbonizing the electric sector, electrifying transportation, and then also electrifying the building stock. And so this state goal is certainly helping to shape a lot of the codes that we're seeing with respect to building electrification. So that part of this triage of strategy is what we're going to be covering today. Building electrification is obviously the most relevant to builders, and particularly this presentation is going to discuss new construction as it relates to code, because that is what is regulated under the building code. And so these are some other California laws that are also helping to guide this transition. So you can see here, Senate Bill 350, this requires the CPUC to focus on reducing greenhouse gas emissions. And we can see other goals coming up through AB 2127, for example, covering the electric vehicle transition and infrastructure. So there's already legislation in place helping to guide this framework and the 2045 deadline that we're facing. So one of the main questions that this begs is, well, what is the future of gas as it relates to California? And that's a very good question. And essentially, to meet California's climate goals, the use of fossil fuels like natural gas will have to decrease by 80% or more by 2050. So there's a large push to consider other alternatives, and this presentation is going to be aimed at how electrification of the building, new building construction can help to achieve these goals. And also, just as a reference, on the right side of the screen, there's a screen grab from Southern California Edison, which is a great resource that displays various ways to put together efficient buildings based on different variables that folks are concerned about, like reducing the most emissions or being able to minimize cost. So this is a great resource from their website. So now we've set the framework of some of the drivers behind electrification in California. How does this relate to specifically building codes, and what are the updates that we can see, especially in the 2022 code cycle that we are in right now as it's pending approval? So these are some things, some changes we can anticipate based on the current code cycle that we're in that would go into enforcement January of 2023. So to begin, this is an example of what the compliance software outputs would look like as you are modeling a building to be able to meet energy performance compliance to then go on to the permitting and build process. And so there's different ways that a designed building can be evaluated. And one of the main ones is EDR, which stands for Energy Design Ratings. And so this is a metric that's, that measures energy use using time-dependent value. And this can be divided into actually different types of EDR. So the efficiency EDR is the energy use by the building as a whole, whereas the total EDR is the energy use net of the solar. And so these numbers can be slightly different because of those different definitions. And as it relates to the building code, essentially the code process, the building code is a set of prescriptive measures for how to put together a house. And so there's two different paths that builders can go through to get compliance to eventually build. So following this prescriptive path is rather restrictive. It tells you exactly the components that have to go into the house for it to meet compliance in a specific location where you are. And so because of these restrictions, builders tend to prefer the performance pathway, which allows for other trade-offs. The catch being that this proposed building that you're modeling has to do as well or better than the standard design as far as energy performance. So the standard design of the house sets the number to beat as far as EDR, and then the proposed design, the way that the builder wants to build it, has to meet that standard design EDR or improve it actually. And so the idea here is that the proposed design uses the same or less energy, and this will allow for compliance. And then the bigger that the compliance margin is, this allows the builder to be able to use trade-offs somewhere else in the construction. And so as far as the updates to the code, the major difference that we're seeing in the compliance software for the 2022 code is this idea of a source energy component, which acts as a proxy for carbon. And so the energy design rating, as I described prior, was based on the energy use of the building and then the offset of the solar system. But now this EDR1 source rating as a proxy for carbon is essentially going to further encourage electricity and renewable generation. And so that's going to be the consequence that we see in the 2022 code as far as compliance software. So this basically is a way around the fact that the Energy Commission cannot directly regulate energy use. They can just provide encouragement or discouragement of certain fuel types based on the way that the compliance software is structured. So this is what we would expect to see in the changes for 2022. And the way that the standard design home is modeled is going to change in 2022 as well. So as you can see, there is a history of mixed fuel being used for the standard design home. But in 2022, there's going to be a hybrid design for the standard design home. So either the furnace or the water heater is going to have to be an electric heat pump design, depending on which climate zone you're modeling specifically. So as you can see for the climate zones listed here, 3, 4, 10, 13, and 14, those are going to have heat pump space heaters in the standard design of the home. And then all other climate zones throughout California are going to use a heat pump water heater in the space, in the standard design for that building. And so this begs the question, okay, well, if the standard design changes based on these parameters, how is this going to affect compliance and then ultimately cost of building that house? So we run through a few examples here that show the impact of changes. And so as you can see on the top of the screen, we've got just a basic code compliant house built with the gas furnace and then also the heat pump water heater as 2022 would specify. And so you can see here that the proposed design actually does outperform the standard design, even if it's a marginal difference. It's still performing better. So that would pass for compliance. But say the builder really wanted to actually use gas appliances for both, and they included a gas furnace and a gas water heater in the design of this basic house. As you can see, the compliance margin completely blows out. You're back down to a -13, which means that you are nowhere near passing compliance to then be able to permit and build this house based on the way that the code is structured now. So how exactly could we comply with gas? Is there actually a way to be able to do that? So we played with that question, and the first step is basically to theoretically improve the features of the house. So say you wanted to keep a gas furnace, keep the gas water heater, well, what could you do to offset that compliance hit and that lower margin? And so we've included all of these features to basically improve the build of this house. So upgrading the walls, upgrading insulation in different parts of the house, upgrading the efficiency ratings of the AC, of the furnace, of the water heater, even moving the ducts from the attic space to the conditioned space of the house. So even after all of these extensive upgrades, the compliance margin is still out. It went from -13 to a -6. So even if you tried to offset using a gas water heater in this build by improving different envelope features and appliance features of the house, even with all of these changes, your building would still not comply and meet the code. So there is maybe one combination of things that would work that we found, and that's using a solar water heater. So this is one potential compliance path with a solar water heater to be able to keep a gas furnace and keep the gas water heater as well. So basically, solar water heater would help to preheat water for hot water systems, which reduces the use of gas. And so this switch theoretically could work. You can see that the margin is positive. So the proposed design outperforms the standard design slightly. However, solar water heaters are not widely used, and you would accrue an additional cost of over $4,000 to make this change. So the way that the code is structured in the compliance software means that really the best option is to actually use the electric appliance that matches the standard design. So this is the implication of the code. And now we're going to go more into, okay, well, if this is the way that California is heading as far as new construction, new residential construction, then what are the costs of actually switching? How would you go about performing these changes to make all electric homes? And what we found is that there are definite benefits in terms of savings by transitioning from mixed fuel to all electric homes. So with the incorporation of all electric appliances, there are reductions in construction costs. And then from there, that can help increase the profit of each home, increase the compliance margin, which, as I mentioned before, allows for trade-offs elsewhere. And then also increasing the number of homes that are sold. And some of these savings can even be passed along to the buyers at the end of the process as well. And so Now we'll get into more specifics of what it would take to make the switch to all electric appliances. And as you can imagine, there are a lot of variable cost figures. There's a lot of people that have tackled this problem and a lot of variability depending on the resources that you cite. And so these numbers that we chose specifically are numbers from an E3 study, which provided a very detailed and comprehensive look at the cost of mixed fuel versus all electric construction throughout the state. And so the numbers that we've isolated here, as I mentioned before, are relative to Climate Zone 9, which represents part of the SCE service territory. And so the numbers that you're seeing here are the costs inside the building. So this represents the appliance and installation and labor costs, everything from the meter into the building. And of course, there can be variability from depending on labor rates, plumbing materials, your location, the appliance manufacturers and people that you're buying from. All of these can affect price. But what we found for a typical 2,700 square foot, 2-story single family home in California, by switching to all electric appliances from mixed fuel, there would be a savings of over $2,000 per home. And for multifamily, there would also be a savings of nearly $600 for each unit. So as you can see, there's some compelling data here that electrification actually increases savings. So another part of this conversation is also the infrastructure costs. So this dealt with everything inside the house, but what about infrastructure costs and savings and how that can impact the switch to electrification? So as you can imagine, if there was a lot of variability with appliance costs, there's even more variability with quotes from infrastructure savings. These numbers can vary widely. So the savings, for example, from avoiding natural gas infrastructure. So depending on who you quote, there can be reported costs between $1,000 and $25,000 per building for infrastructure. And so there is quite a hefty range of people's experiences. But what we found in our analysis of invoices for new subdivisions in California, we see a savings of about $1,500 per house. So by being able to avoid this gas infrastructure. So, but as I mentioned before, a lot of this is very specific to where you're building. So people's experiences all over California can change. For example, whether you're building a city infill project and the gas main is right outside the front door compared to a subdivision in suburbia that's starting from literally nothing. So that can impact the type of infrastructure that has to go to the house to be able to connect to those utilities. So there's a wide range of experiences, but yeah, our analysis shows invoices of new subdivisions showing infrastructure costs of $1,500 per house. That would, those were the savings that we would see. And of course, it's project specific, and this would, yeah, vary depending on where you're building, but there can also be infrastructure savings that are seen in the switch to electrification by being able to avoid gas. So far we've talked about things relevant to the builders. So now what about the customer's experience, being the person living in the home? So how would electrification affect them? So assuming that they're living in this all-electric new residential home now, what would their utility bills look like? That is the biggest indicator of how this would impact them being able to run the operational costs of this all-electric house. And again, there is variability depending on where you live, who your provider is, what kind of a rate structure that you're on. But these figures from SoCal Edison territory show a very marginal cost for single family homes and a small net savings for multifamily units. And this actually is over the period of 1 year. These are the numbers that you would see. And so as you can imagine, a cost of $59 divided throughout an entire year is obviously like subject to change depending on a lot of factors in the house, like appliance efficiency, insulation of the house, or even just general use patterns of the people that are inside. if you shift that away from peak hours, then that would be the cost that you would be able to avoid. So yeah, the numbers are so small, marginal, that they're definitely subject to change just based on people's behaviors in the house. So ultimately, there would not be a huge penalty that people in single family homes would see on their utility bills by having all electric appliances running in their homes. And just to clarify, if people were wondering, a multifamily unit here is defined as it's an 8-unit, 6,000 square foot CEC building. So that's the frame of reference when I use the term multifamily. That's what that looks like. So then, now that we've talked about some of the benefits that can be seen, what are the individual changes that would have to happen in order to actually switch out all of these individual appliances and make the house all electric? So we're going to start with some of the concerns that consumers might face, being the ones that are going to be moving into these homes at the end of the process. So we're trying to basically anticipate any reticence that customers might have and how we can turn these challenges into opportunities. Especially during the home buying process, customers can be very particular about what they're looking for. And so we're going to try to provide options for them and basically spin the narrative into benefits that they can see with each of these individual appliances. So to start out, we will go through the appliance change for a heat pump water heater. This is something that maybe folks are already familiar with as being a very efficient piece of technology. So the first hurdle here is that the standard nowadays is the tankless gas water heater. And so people have adjusted to the idea of not having a tanked system. And so we would have to be able to warn them on the idea of going back to a tanked heat pump water heater if they were to switch. And so one of the concerns that builders have here is that customers are going to experience like a lack of unlimited hot water by not having the tankless gas system. And so there are a lot of builder reservations that customers' experiences might be limited by the amount of hot water that they have, and that there would be a lot of complaints because of that. But as it turns out, this doesn't necessarily match customers' actual experiences. It's more just a presumption that customers will run out of hot water without having the tankless system. And so that doesn't necessarily match what people actually experience. They're not very likely to actually run out of hot water by using a tanked heat pump water heater system. And so that's something that we can use to quell any builder's fears that customers might complain. That's not necessarily the case. So this reticence for builders is based more on assumptions than the reality of customers' concerns and experiences. So home buyers, one thing that we also have to anticipate is that people living in the home will notice that it takes slightly longer for these types of water heaters to heat up. Effectively, what you gain in efficiency, you lose a little bit in speed. So they do tend to have a lower first hour capacity. So one of the easiest solutions to this is just sizing up one from the gas model that would otherwise be the equivalent. And so this is something that can be easily remedied, and all these considerations can be explained and talked through. And this transition is worth it for the increased energy efficiency that you would get from the heat pump water heater. And then in terms of practical costs, here's a comparison of some of the hardware costs that we see from a CEC presentation actually. So this offers a different comparison of what people could find readily available now, even just from Home Depot online. And so this shows that there is very little price difference between a tankless water heater and a 50-gallon heat pump water heater alternative. So that should not really be a concern to builders or customers. And also there's an additional savings by being able to avoid a flue and gas piping from the meter that you would otherwise need to have. So there's also some savings that can be seen from the avoided infrastructure costs, as I mentioned before. So the next appliance to consider is the heat pump HVAC system. So again, as I just mentioned, this has a bit of a simpler installation than a mixed fuel equivalent. That's a benefit right off the bat because you only need one indoor unit versus having to have the heat exchanger and the furnace for a gas alternative. One consideration here for this appliance change is the fact that in most climate zones throughout the state, the heating and cooling loads are not perfectly matched for each other. So there can be the potential of an upsizing issue. So one way to address this, if there's the heat pump the heat pump has to be sized for the larger of the two loads, whether it's heating or cooling, depending on where you live. But this is becoming less and less prevalent with variable speed units that are better at coping with partial loads. So there's improvement in the technology here. And then additionally, being able to upsize the model, it helps to alleviate some of these concerns. So this is another thing that could be easily sold as an improvement to the customer, especially with simpler installation than mixed fuel and the avoided gas infrastructure. So again, here are some real world examples of wholesaler online pricing right now. So these are some more hardware costs from the CEC presentation. And again, we see a minimal cost difference between the gas and electric split system and the dual fuel heat pump. So this is just another example showing that people might have perceptions that the electric appliances are always going to be so much more expensive, but that's not necessarily the case in real world examples. So another appliance to consider is the heat pump clothes dryer. So this has some pros and cons to it, just as a lot of things we've discussed. From the beginning, it has a similar price per load to a gas dryer. So right away, that's a difference that wouldn't affect the customer. It's a similar price per load to the gas dryer that they're used to. And then again, as I've mentioned before, there's avoiding certain infrastructure, like in this case, the use of venting. So the installation is more streamlined for a heat pump clothes dryer. One thing to take into consideration is that the drying times, cycle times are going to be longer than what customers might experience now with gas models. And so this might seem like a pretty big downside, but it can actually be sold as a benefit to customers by saying that the cycle is gentler on your clothes and buyers are less likely to experience any damage or shrinkage if their clothes are left in the dryer for long periods of time. So this may seem like a downside at first, but it can be sold and spun in a way that is a benefit to the resident of the home. So then we've covered a lot of appliances so far that could easily be remedied and sold to customers as a beneficial change. But the one that people do tend to get stuck on is how they cook. And people have a real soft spot for gas ranges and cooktops. So that is one thing that we really have to work to educate customers about different alternatives that are available now. Of course, there's a lot of benefits to gas. People really love the instant temperature control, how quickly it heats up, being able to actually see the flame and gauge how hot things are. But there's obviously some downsides too about indoor air quality and safety concerns because you're working with an open flame. And so one of the biggest obstacles here is going to be essentially educating customers on all the improvements that have been made to electric cooktop technology. And in this case, I'm talking about induction. Induction has come a long way and it offers a really cool piece of technology that people might not be familiar with and might not understand how it works, and that it can provide a really beneficial alternative to cooking with gas. So induction, for folks who might not be familiar, induction doesn't actually heat up the cooktop, but rather it uses magnetic fields to heat the pan itself. And so in this way, there is better efficiency when you're using induction cooktops, and the cooktop itself is not hot even after you remove the pan. And so it's much safer this way. So there's less risk of burn, and you're not working with an open flame in the kitchen. So this is something that has real benefits to consumers, but folks might not know about it or might not have experience with it enough to actually change their mind and be willing to give up a gas range. And so for this purpose, specifically SMUD, the Sacramento Municipal Utility, they actually conducted a research program where they basically gave customers single plug-in induction cooktops and then rated their satisfaction and approval of that before and after having the experience with using it. And so by allowing people the chance to use this technology and test it out themselves, approval went up from something like 20% before the study to over 80% after the study was done and customers had a chance to use the technology themselves. So this just goes to show that this might seem like a really big hurdle now, people's preferences over cooking fuel, but with some education and some different tools and resources, this is definitely a selling point for customers and home buyers if they have experience of using induction stovetops. So this can be something that is more easily sold if people have hands-on experience with it. And if people actually, fancy themselves to be chefs or, hobbyists in the kitchen, another resource is the fact that chefs love using induction cooktops, and there's a lot of sponsored content and demonstrations that you can find online of different professional chefs just raving about how much they love induction cooktops. So this could be another potential selling point if people really have reservations about giving up a gas range. This might be something that influences their opinion that professionals in the industry even prefer using induction. So now that we've switched out all of these appliances to electric, one question that folks might have is, well, how will this actually impact the panel sizing in the house? Is there any need to size up or change standard construction practices now to accommodate larger loads? And the long story short is no. So here we have an output of basically different load sizes for different single family electric house scenarios. And these figures are straight from an electrician and how they would wire a house. And so as you can see here, there's different combinations of electric features grouped together, ranging from lower draws to higher draws. And even with this range of options and different scenarios that are mapped out, all of them would still be serviced by a 200 amp panel, even with additional features like induction and heat strips that take larger loads. So even with these as a consideration, when we're comparing these different single family all electric scenarios, each load would still be accounted for with a 200 amp panel, which matches current new construction practices. So there would have loads would not have to be accommodated with a larger panel. This would align with how new homes are currently being built. So no special modifications would have to be made for an all electric house. So another consideration when you remove gas from a house is obviously the indoor air quality. And so this can be another major selling point that builders and of course occupants of the house care deeply about. So there's been a lot of different pollutant studies about how different appliances, gas-based appliances, can affect the indoor air quality of a home. And the open flame stovetop is a considerable source of indoor air quality pollutants in a home that can be easily mitigated with an electric alternative. So studies have shown that changing this fuel type for cooking has a bigger impact on indoor air quality than even using a range hood. And of course, ventilation is important, but studies have also shown that that's not something that homeowners are consistently doing as they cook. So the biggest benefit can be seen by switching out the fuel type of the appliance. That can make the biggest impact on pollutants from indoor appliances. So as I mentioned, yeah, it's really about the air, and that's a budding concern that a lot of people are paying attention to, especially as we're coming out eventually of a global airborne pandemic that we're slowly recovering from. And then of course in California, we experience pretty scary fire season. So these are all things that impact air quality. And of course, this is a major concern that's at the forefront of people's minds. So being able to improve indoor air quality in a home is definitely a selling point for peace of mind and safety. So another question that folks can often have is, well, with all these electric appliances in a house, how is that going to affect solar and storage? And so as most folks are probably familiar with, there's a new 2019 code cycle requirement for solar on residential new construction. So this is something that a lot of folks are considering as we get closer to finalizing this most recent 2022 code cycle. And so ultimately, the first major concern is that there will not be any differences in the minimum PV requirement. That should not change between the 19 code cycle and what we're going through for 2022 now. The major difference that people are going to see is that basically it's easier to install a larger PV system for houses that are built above code. So the thought process here is that if you're using more electricity in your house now, then utilities would be happy to have you generate more. So it's easier to increase the size of your PV system if you are building above code in the case of like Z&E or all electric housing. So that is one benefit that people can see there. And then this also plays into the idea of battery storage, how that will be affected by all electric new construction. So battery storage now is still a relatively niche market, but it's going to be expanding in coming years. And so storage obviously has a lot of benefits in and of itself by reducing differences in energy demand between peak and non-peak hours. So the idea here is that you get to store energy during off-peak hours when electricity is being generated, and then use that later in the day during peak time of use times. So that's the major system that would come into play here. And there's also a slight compliance benefit for builders. So adding a battery to the house allows for a reduction in the size of the PV system of the home. So as the code is written, including a battery of 7.5 kilowatts or larger allows the PV system to be reduced by 25% if those are used in tandem. So that is also a benefit that can be seen if people do invest in incorporating the battery into the structures of the home. And so here we can see more specifically of what that would look like. And as I mentioned before, it's still a relatively niche market, and battery storage does have a fairly high cost to savings ratio, but this will likely reduce over time as they take up more space in the market. And also there's a definite benefit for the idea of resiliency too. So this is something that customers can also factor in when they're deciding whether or not to invest in this. And yes, so battery doesn't quite pay for itself on a reasonable timescale yet, but this is likely going to change. So that is something to look forward to in the future. So as I mentioned before, the idea of electrifying new homes may seem like cutting edge, the wave of the future, but there's already some developments that exist that are an example of all electric new homes. And so these are some examples of all electric communities that are being promoted by utilities. So they don't necessarily just exist as something of the future. Improvements are already being seen now, and these are practices that are already happening. And so I'm going to run through a few examples of project spotlights and developments that are already up and running. So the first thing here we see is City Square in Irvine, California. So it's a development of townhomes, and they range between $845,000 and $900,000, which by California standards is not is not that bad, but folks from out of state might be a little bit shocked by that. But yes, these are examples of Southern California's first zero net energy townhome community. And this was a partnership with SCE to demonstrate the technical and economic feasibility for all electric multifamily homes. And so these are some of the feature specifications. So you can see here different construction decisions about lighting, appliances, R13 wall insulation, R4 styrofoam continuous insulation. So the point here really is that none of these construction practices or appliance choices are like completely out of the ordinary. Like there's nothing extraordinary or well beyond code to make this possible. These are like construction practices that people are familiar with, and in combination, this community is possible based on these decisions. So it's possible to create projects that are not totally extraordinarily like off the book with all the benefits of all electric at the same time though. And then another example here is this Atwood development. So this is a combination of townhomes and live work lofts in Covina at a different price point, slightly lower. And so this was completed actually in 2019. And yeah, it's an example of live work lofts, townhomes, and some mixed use retail. And so these are some more specifications of the construction practices for building this development. So there's some rooftop solar, Energy Star appliances, heat pumps, electric vehicle ready, and then net smart thermostat. So again, like these are construction practices that exist now, technology that exists now, and this is an example of being able to pair these things together and achieve this desired outcome. And then another example here is the Silver Star Apartments. And this is actually a special needs community for homeless and disabled veterans. And it is an example of the first ZNE multifamily affordable housing project in Los Angeles. And so you can see here that it was completed in 2019. And it provides an example of this really special project. And so these are some of the features that we can see of how it was constructed. So 2x6 framing, R21 insulation in the walls, R30 insulation in the roof, and just different features that are efficient, but not like blowing code out of the water necessarily. And then one unique factor to include here is the addition of a mini split system for each unit. And so that provides a different example of a very efficient HVAC system that could be beneficial in multi-unit housing developments. And then also this is an example of different certifications like LEED Platinum and Energy Star. So a lot of other benefits to this project as well. So now that we've gone through all of these examples of what it would take to change to an all-electric construction, and also examples of it working in real time currently, yeah, SCE is definitely interested in helping with electrification, and I'll provide some resources here. So even, yeah, just online, there is an all-electric new homes showcase that people can access. There are showcase homes that are being built and promoted by the building industry associations. So all of these can be seen and mapped out online, which is a really cool resource. And then, as I was mentioning earlier, yeah, induction cooking might be one of the harder sells as far as customers who are eventually going to buy these homes and move into them. And so SCE actually has this really cool tabletop induction lending program as an educational tool to help inform purchase decisions. And so this is a program that's back up and running, and there's an induction unit request form that's available online on their Food Service Technology Center website. And that's currently a feature that's open to SCE residential and commercial customers. So if people were considering induction cooking or on the fence about it and they live in the SCE territory area, this could be something to help sort of give them experience and quell some reservations they have about giving up gas cooking. And then, of course, we'll go through questions that Will has been moderating in the chat. But if I don't get to anything or we run out of time, here's our contact information. Feel free to send a follow-up or ask more specific questions there. But yeah, that covers the information. So how is the chat looking?
Thank you so much, Amy. That was excellent. Will's been tackling questions in the Q&A box as they come in. So I don't see anything outstanding. Maybe we have a little poll just to see who's joined us here today. So maybe we can launch that poll and give folks a couple of minutes to post any questions they have. But if you don't have any questions, we'd love for you to take this poll just so we can kind of understand who's joined us today and what level of understanding you have and what else might be helpful. So please do take that poll. It should have popped up right in front of you just now. And while people are doing that, Kenneth, sounds like you're already an induction fan. That's great. I'm also trying to talk my husband into getting induction, so maybe I can use some points from this presentation to help encourage him. Oh, Will, you're on mute if you want to unmute.
Mute. Okay, can you hear me now? Great. Yeah, I actually got an email from my aunt yesterday inquiring about induction cooktops. So it's obviously something that people are starting to learn about. But yeah, the thing I actually recommended Costco to her. So Kenneth, you know, you're in good company there. Yeah, that is an easy way to decide whether or not induction cooking is something you really want to sort of spend the money on. Because a full-size induction cooktop is going to cost several $100s and may require installing, running a 240 volt supply, because you don't necessarily have one where that cooktop is. So it can be quite an investment. Depending on which utility territory you're in, there are rebates available, some of which are obviously more generous than others, that can help defray that cost. And obviously whether you've got a 24-inch, 30-inch, 36-inch wide cooktop makes a significant difference. Just had one question popping up in the chat. Installing a heat pump water heater requires a permit. Yes, it does. It requires, pretty much installing anything requires a permit. It's a minor permit rather than a major one. And typically most plumbers will be able to handle that for you at comparatively little cost. And I would say that anyone who is installing a water heater and doesn't want to get a permit is someone you should probably think twice about hiring.
And I'll add in, if you're not in Southern California Edison service territory, there are some programs, like if you're in the Bay Area, the organization called Bay Run has a Home Plus program that has a lot of information about rebates, and they have a list of contractors who already know about the rebates and can kind of automatically apply them for doing this work. They'll get the permits, they make it very easy, and they can help you kind of understand what's the right size model for you. So definitely look around for rebates if you're going to do any of these things. Some of them go directly to homeowners, some of them go directly to contractors, but there's money available to do these things. Any other questions? Okay, Peter, we just got one from Peter, Will.
Any thoughts on using an electric vehicle as battery storage? That is technically feasible, but most it's not as simple as simply plugging your car in and telling the system it's a battery. You need to have a two-way charger. Not all vehicles are suitable are designed to run that way. So it's more, it's something that's certainly being looked at, because obviously the cost of battery storage is high at the moment, and even if it comes down, it's still going to be a significant investment. And if people are getting, you know, electric vehicles, it makes a lot of sense to combine the storage capacity of your vehicle with your home storage. Yeah, so Mr. Bosch has just answered that question for me. Is a transfer switch installed or a bidirectional charger? So yeah, it is feasible, but it's not necessarily straightforward. And that's the limit of my expertise. You would need to consult with someone who specializes in home storage to do that properly and safely.
All right. Any last questions? Want to get in under the wire? Get them out now. All right. Well, if you do have more questions, feel free. There you go. Debarshi's just put his email in there. We'll post Big's email if you want to follow up. Amy and Will's emails are also up on the screen right now. If you have any additional questions to follow up, we'd love to help get those answered. Amy and Will, thank you so much for your time today and sharing all of this information. It was a lot of information, and so if you want another look at it, like I said in the beginning, we'll be sharing a PDF of the slides as a follow-up to this session. Thanks, Will and Amy. Thanks, Consul, and thanks everybody for joining us. We hope you have a great rest of your day.